In this video, I want you to learn how to combine like terms and then to use the distributive property. So first of all, you need to know what terms are. Terms are separated by plus and minus signs. Notice here that the 7 is multiplied by the x, but 7 times x is considered all one term. So terms are just separated by plus and minus signs. So here I see this expression has 4 terms. Some terms are variable terms. Here are examples. Some terms are constant terms. Now the difference is that constant terms always have the same value. For example, every time you see this term, it has a certain value. But every time you see this term, it does not have the same value. Here, if x is 1, the value is 7, but if x is 2, the value is 14. So variable terms are called variable terms because their value can vary or change. I want you to be able to combine like terms. Combine simply means to add. So for example, in this expression, you can combine or you can add a 7x to a negative 4x because they are like terms. But when you start to write your answer, you want to write it in what we call descending order. Notice that there are x terms and there are y terms. So we would put the x terms first. In descending order, that is, we would put an x cubed term before we would put an x term. Now notice I got the 3x by adding the 7x and the negative 4x. Now I also have a y term and I also have a constant. So you write your answer in descending order, which means the constant always comes last. So what are like terms? Like terms have to have the same variable and the same exponent. For example, these terms are like terms because they both have the same variable with the same exponent. So these are both m cubed terms. Now what do you get when you add two m cubed terms? Well, just like when you add apples to apples, you get apples. When you add an m cubed term to an m cubed term, you get an answer that is an m cubed term. So you just add the coefficients or the numbers in front of the m cubed. So 4 plus a negative 7. The signs are different, so I'm going to subtract and use the sign of the 7 since it's further from 0. So the answer is negative 3m cubed. Now I want you to think about the order of operations. Looking here on the left, according to the order of operations, you would do what's in parentheses first, then you would multiply. But on the right, I'm going to show you where I am actually going to violate the order of operations. I'm not going to follow the order of operations, and yet I'm going to get the same answer. I'm going to multiply the 3 times the 4 first, then I'm going to multiply the 3 times the 5, then last of all I'm going to add. Notice I got the same answer. Did you know this process always works in a situation like this? So I can always violate the order of operations in this particular kind of situation, and yet I'll always get the right answer. Now when that happens, when we see a pattern that always works, we call it a rule or a law. This rule or law is called the distributive property. So when do I use the distributive property? Well, notice on the left here, by using the order of operations, I only had to do 2 calculations. I added once, and then I multiplied. But on the right, when I used the distributive property, I multiplied twice, and then I added. So actually, using the distributive property was harder. So why use this pattern if it's more difficult? Well, we don't use the distributive property in a situation like this because it is harder. So if I ask you to simplify this expression, you would not use the distributive property. You would go ahead and use the order of operations to do what's in parentheses first because it's easier. So when do we use the distributive property? Well, we use it in a situation like this. When you have a variable in your expression and you've got the parentheses, then we use the distributive property to simplify. Because I cannot use the order of operations, I can't go ahead and add the x to the 2 because I don't know what x is, so I can't add the x to the 2. therefore, we use the distributive property to simplify, because in algebra, if an expression has parentheses in it, we consider that it's not simplified. So we want to simplify it, so let's use the distributive property. So I'll multiply the 4 times the x, the 4 times the 2, and now I have simplified this expression because it has no parentheses. Now I cannot go ahead and add the 4x to the 8 because they're not like terms. I can only add an x term to another x term. Here's another example. So since I cannot go ahead and use the order of operations because I have an x here, I'm going to use the distributive property. Now pay attention to your signs. The signs are different, so the answer is negative. Here again, the signs are different, so the answer is negative. Now, the number on the outside that you're multiplying by does not have to be on the left side of the parentheses. It can be on the right side of the parentheses. So here I can multiply the negative 3 times the 3x. Signs are different, so the answer is negative. Then I can multiply the negative 3 times the negative 2. The signs are alike, so the answer is positive. So here is the distributive property written using variables. So all I'm saying here is that if you have a number on the outside and inside the parentheses you have an addition problem, either b plus a positive c or b plus the opposite of c, then you can use the distributive property to simplify and get rid of the parentheses. Now let's put these two skills together. Let's use the distributive property and then combine like terms. So I can multiply the 4 times the x, the 4 times the 6. I can multiply, now notice this is not just a 2, it's a negative 2 times the x, a negative 2 times the negative 5, a negative times a negative gives a positive. And now I can combine the x terms, I can combine the constants, and so my answer is 2x plus 34. Let's try that again. So I can multiply the negative 4 times the 7. Signs are different, so the answer is negative. The negative 4 times the negative 1y. Signs are alike, so the answer has a positive sign. I can multiply the 5 times the y, the 5 times the negative 3. And now I can combine like terms. We want to write our answer in descending order, so we want to put our y terms first. And then we want to add our constants. The signs are alike, so I add and keep the same sign. So notice here, if I ask you to simplify, notice the 15x, the 15 is positive, but notice that the 4x has two signs in front of it, a positive and a negative. So let's use our multiplication rules to simplify. Since there's only one negative, I'm going to replace both of these signs with a negative sign because 1 is an odd number. And then I can combine like terms. They're both x terms, so I can add 15 to negative 4 and get 11x. So here I can use the distributive property. Now notice I just brought down the plus y. Now I can add the y terms and just bring down the constant. Now here notice I'm going to be dealing with exponents, because when you multiply a 5x times an x squared, now you can multiply an x times an x squared. You can't add an x to an x squared, but you can multiply anything. So how do you multiply an x times an x squared? You just add the exponents. So an x to the first power times an x to the second power gives an x to the 1 plus 2, which is a 3. And then a 5x times 3 would just be a 15x. A negative 2 times x cubed is negative 2x cubed, and a negative 2 times x is negative 2x. Now I can add the like terms, so I want to put my cubed term first. Now notice when you add that the exponent does not change. When you multiply, exponents can change, but when you add, exponents do not change.